Welcome to this Angular training by Coding Jobs. Coding Jobs is the best e-learning platform to learn Angular, practice with great live coding exercises and videos, and apply for jobs. My name is Isam and I will be your instructor. How can I improve the performance of my application using Chrome DevTools? Today, any application must focus on user to success. Performance is a key factor for end users to win against competitors. The performance is how your page performs when it is running. A user will be happy if the performance is great. For smooth animations, your frames must run at least 60 frames per second. A response to events below 100 milliseconds will be immediate for a user. A response between 100 milliseconds and 1 second will be natural on loading and browsing, for example. A user will not be happy if the response delay to click, browsing or page load is above 1 second. He will lose the focus on the task. A user will be frustrated if the response delay is beyond 10 seconds. He will give up the task. To measure the performance, we use Rel Performance Model. It stands for Response, Animation, Idle, and Load. Response must answer under 50 milliseconds. Animation must be rendered at most at 16 milliseconds, which is 60 frames per second. Idle time need to be maximized to make page respond within 50 milliseconds. Load to deliver the content of the page and become interactive in less than 5 seconds. To demonstrate the benefits of Chrome DevTools Performance Tab, we will use the Jank demo page provided by Google Chrome team. We can simulate two modes. Fast mode by clicking on Optimize button at the top left of the application. Slow mode by clicking many times on Add 10 to increase the number of visual blue elements on the screen, and make the application slower. You can slow down CPU by adding throttling multiplied by 6. To open the Chrome DevTools, we first recommend opening Chrome in incognito mode. For Mac users, press Command plus Option plus I. For Windows and Linux user, press Ctrl plus Shift plus I. Then, select the Performance tab. Open the Performance tab. Click on the Record button to start the performance analysis and Stop blue button to end the recording. To clear the performance view, press the Clear button. Here are the performance recording results. At the top is the demo application running in the browser. At the bottom is the Performance tab of the Chrome DevTools console. The Chrome DevTool is enabled in Mac with Command plus Option plus I. For Windows and Linux user, with Ctrl plus Shift plus I. The x-axis is the user activity timeline in milliseconds. The CPU chart shows how busy is the CPU in the timeline. JavaScript activity is yellow and layout work is purple. The frame chart indicates how long a frame takes. There are 4 frames types. Idle frames are shown in white, showing no changes. Rendered frame on time are displayed in green. Partially presented are yellow, it means late animation. Dropped frames are red and are not rendered. The main flame chart shows the activity on the main thread. Red triangle and CPU or main view indicate warning. The x-axis represents the recording over time. The y-axis is the call stack, the JavaScript functions. The summary shows the CPU color legend. The bottom-up describes the activity taking most time to aggregate. The call tree shows which root activities cause the most work. The event log lists activities in the order they occurred. To analyze animation's performance, locate red triangles in both CPU and main view. You can also display FPS meter overlay from rendering menu option. A frame should run at most 16 milliseconds, which is 60 frames per second. Here are some red triangles showing performance warnings. They are displayed in the main flame chart. You just need to click on the stack with triangle. It will show the root caused in source files. Each line in app update function shows time delay. You need to focus on the line taking the most. Here we change the style and position, which force relay out blue squares in our application. The solution uses composite properties skipping relay out. To fix the performance properly, You need to understand the rendering pixel pipeline. It consists of 5 steps. The JavaScript handle tasks resulting in visual changes. The style recalculation finds CSS rules for each element and compute final style. The layout compute space between elements and screen position. The paint step fill the pixel, drawing text, colors, images, borders, shadows on multiple layers. The composite step orders the layers so that the page renders properly. If you change the width, height, top and left position, then the browser will run layout, paint and composite. If you change the background image, text color, shadows, then it will run paint and composite. If you run the transform and opacity, then it runs only the composite. You should use transform and opacity for high-performance rendering. These are our guidelines. Enjoy. We run performance analysis on Google Jank demo website. First open the Chrome DevTools and select Performance tab. Then click the record button to start a new recording. Click the stop button after 4 seconds to show the result on the selected timeline. It takes a few seconds to display the performance record results. It runs a performance profiling. Chrome starts loading the profile, then it will process the profile and display the results. Here you go, the performance recording has finished and we can start analyzing the results. We select a timeline with red color showing warnings. Select a small timeline to reduce the analysis scope. Then, locate red triangles in the main call stack. It shows a performance bottleneck. Click on the call stack with red triangle to show the source of the issue in the event log. Identify the function and source lines in the code with the highest delays. Here the style and position are changed. It relayout squares to compute positions. The solution here is to use composite property like transform and opacity. Enjoy.